I wanted to show you one more example of analyzing a graph of a rational function that has an oblique asymptote and how we can look at whether or not the function crosses that oblique asymptote. So I have this function r of x is equal to x squared minus x minus 12 over x plus 1. I've factored it, looked for the x-intercepts, the y-intercept, the vertical asymptote, the horizontal asymptote, and the oblique asymptote. I did find that there's an oblique asymptote of y equals x minus 2. If you want to know how to do that, you've got to watch an earlier video from section 4.2. But now we're going to answer the question, does our function cross that oblique asymptote? Well, remember how when we looked to see if something crosses the horizontal asymptote, we set the whole function equal to the y value on the asymptote? Well, instead now we're going to take the entire function r of x and say, does it ever equal x minus 2? Think about systems of equations and how you can set them equal. If you had y equals some value and y equals another value, involving x, you could set them equal to each other to find their intersection point. Well, that's exactly what we're going to be doing here. So I'm going to take the original function in its non-factored form, x squared minus x minus 12, all over x plus 1, and I'm looking basically to see, are those two things ever equal, for any x values. And if we find the x, we could plug it then into our function or into the asymptote to find out the y coordinate of where that happens as well. Alright, so let's go ahead and solve this. If I multiply both sides by x plus 1, on the left-hand side I'm left with x squared minus x minus 12, and on the right-hand side I can multiply these out to get x squared minus x minus 2. I can subtract x squared from both sides and then also add x to both sides. Look what ends up happening. I get negative 12 equals negative 2. This is not a true equation. There's no solution to this equation. So what that means is that this original statement, are these two things equal? The answer is no. The answer is no, not equal for any x value whatsoever, right? So we'll say no. So we'll say that r of x does not cross the oblique asymptote. Now we're going to take a look at this function and think about when you graph, what does an oblique asymptote look like? How do you kind of graph near one? Okay, so our vertical asymptote is x equals negative 1, that's right. We know that our x-intercepts are 4, 0, and negative 3, 0, right? And we also know that the y-intercept is 0, negative 12, so let's just put that down here. And then the oblique asymptote is the line y equals x minus 2, right? So I'm going to write that here so we can see it. That has a y-intercept of negative 2 and a slope of 1 because it's 1x. So it means from this point, this 0, negative 2, I'm going to go up 1 and over 1 to the next point. Up 1 over 1. Up 1 over 1, right? And we'll continue on. So this is our oblique asymptote. I can tell by the points on the function that our graph is going to look something like this. It might be a little bit more smooth. It probably doesn't approach the asymptote that quickly. But we have to go through 4, 0, crossing there, and we also have to make sure that the function approaches this oblique asymptote here, as x goes to infinity. We also have to make sure that it approaches it as x goes to negative infinity. Plus, we have this vertical asymptote, which we know we can't cross. So we can see that the function is going to continue to go down, oops, according, down and never really cross that that vertical asymptote. And we also see that it's going to go up and never cross there. So it's going to, the scale of my graph isn't looking so hot. I'm going to draw it a little bit without points so you can just kind of see the general shape, right? So it's going to kind of do this and kind of go like that, And so you can see that it's approaching the asymptotes in the correct way, and it's indeed a function because it would pass the vertical line test.